Welcome to the pre-calculus notes for chapter 2.4 titled Complex Numbers. Go ahead and print your first and your last name and what period you're in. The first thing we're going to talk about is the imaginary unit. So some quadratic equations will have no real solution, such as the equation x squared plus 1 equals 0. To overcome this imaginary unit, the imaginary unit was defined. And I will be equal to the square root of negative 1. And I squared will be equal to negative 1. If you have a highlighter, go ahead and highlight this guy. If you don't have a highlighter, put a star or a circle. You'll keep coming back to these two pieces of information. Complex numbers are obtained by adding a real number to real multiples of the imaginary unit. A will be equal to 0 and B will not equal 0. The complex number bi is an imaginary number. Here's also a little tidbit of information. Two complex numbers, a plus bi and c plus di, can be equal to each other if a equals c and b equals d. But let's get into the meat of it. Okay, so we're going to look at operations with complex numbers. The first two are super easy. They're going to be the addition and subtraction. And if you're good at recognizing like terms, then this part should be easy for you. You're simply going to take 5 plus 7i plus negative 3 plus 4i, and you're going to combine any like terms that you have. So the 5 and the negative 3 combine to get 2, and the 7i and the 4i combine to get 11i. So adding is super easy, okay? Subtraction works the same, except for you're going to subtract. So you just have to watch your signs and remember that minus a negative means to add. So if we have 5 minus negative 3, you get 8. And you have 7i minus 4i, you get 3i. Okay? Again, just watch your signs on those, but it's basically combining like terms. All right? Now let's talk about the additive inverse. Okay, so if these are opposites of each other, and they will go to 0. So 3 plus negative 3, you get 0. Negative 2i plus 2i goes to 0, and you have 0i, so this just equals 0. So you can end up with zeros in your answers. All right, and then let's talk about the powers of I. So I to the first power is just I to the second power is negative 1, I to the third power is negative I, and I to the fourth power is 1. Then what's going to happen is it's going to repeat. So I, negative 1, negative 1, negative I, 1, 1. So essentially, if you have I to the 35th power, that's like I to the fourth. So any multiple exponent that is a multiple of 4, 8 times is going to get you 1. And then there's 3 more left over. So I to the third is negative 1. Or sorry, negative I. So the answer is negative I. So you're going to take the exponent. You're going to see how many times 4 can go into it. And then how many are left over. So in this case, 3 were left over. That means I to the third, which is negative I. Okay? All right. Now let's talk about multiplying complex numbers. So we added and subtracted. Let's multiply. Use the bell. 4i times negative 5i. So 4 times negative 5 is the negative 20. And I times I is I squared. Well, if you go back to the highlighted part, your I squared is negative 1. So you simplify by multiplying negative 20 times negative 1, which is positive 20. All right, what if you have a binomial times a binomial of a complex number? So you're going to FOIL. You're going to go 2 times 6, which is 12, 2 times 11i, which is 22i, negative 3i, negative 3i times 6, which is negative 18i. I wrote it directly underneath because those are like terms. And then negative 3i times 11i is negative 33i squared. And then I squared, it simplifies to the negative 1. So we'll get there in just a second. But bring down the 12 because it's its only like term. 22i minus 18i is 4i. And then the negative 33 times the negative 1, which is positive 33. So the 12 and the 33 combine to get 45. And then we've got 4i. All right, let's talk about multiplying complex numbers. This time we have 3 binomials. So we're going to multiply the first 2 binomials, simplify it, take that answer, and multiply it by the third binomial. So 1 times 3 is 3. 1 times negative I is negative I. Then we do the inside. 2i times 3 is should be 6i. And then 2i times negative I is negative 2i squared. So that. Okay, so I found an error in that one. Let me fix it. So we've got the 1 plus 2i times the 3 minus the I. I'm going to do it over here. And then once we get that answer, we're going to take it and multiply it by 5 plus 4i. So we're going to do first, which is 1 times 3, so we get 3. And then we have outside, 1 times negative I is negative I. Inside is 2i times 3, which is 6i. And then last, so 2i times negative I, so negative 2i squared. These two are going to combine, but let's simplify this first. So I squared is negative 1 times negative 2 is 2, and 3 plus 2 is 5, so that's where this 5 comes from. And then negative I plus 6i is 5i. So that all simplifies to 5 plus 5i. We're going to take that binomial and multiply it by the third binomial, 5 plus 4i, and we're going to FOIL again. So 5 times 5 is 25. Outside is 5 times 4i, which is 20i. Inside is 5i times 5, which is 25i. And last is 5i times 4i, which is 20i squared. I squared simplifies to negative 1, which makes that negative 20. So 25 minus 20 is 5. And then 20i plus 25i is 45i. All right. Now we're going to multiply conjugates. So notice that these two binomials are basically the same, except where they have opposite signs here. Okay. It just means that when you FOIL it out, you're not going to have a imaginary part of your complex number. Okay, so first is 5 times 5, which is 25. Outside is 5 times 7i, which is 35i. Inside is negative 7i times 5, which is negative 35i. Notice these become opposites. They're going to cancel. And then we have negative 7i times positive 7i, which is negative 49i squared. I squared is negative 1, which makes that positive 49. Combine that 49 with the 25, and you get 74. All right, and the last slide. Okay, I times 7i is 7i squared. I squared simplifies to negative 1. Negative 1 times 7 is negative 7. We've got 8 minus 7i squared. So we're going to write it out as a binomial times a binomial and then FOIL it. First is 8 times 8, which is 64. Outside is 8 times negative 7i, which is negative 56i. Inside gets you the same thing. And then last is negative 7i times negative 7i, which is positive 49i squared. I squared becomes negative 1, which makes this negative 49. So 64 minus 49 is 15. And then combine these two to get negative 112i. And then the last one, we've got the square root of negative 5, which I'm going to separate to square root of positive 5 and square root of negative 1, times square root of negative 15, which I'm going to separate to square root of positive 15, times the square root of negative 1. Square root of negative 1 is I, square root of negative 1 is I times I is I squared, which becomes negative 1. And then the square root of 5 times the square root of 15 is the square root of 75. This 25 is a perfect square factor. So I'm going to rewrite the square root of 75 as the square root of 25 and the square root of 3. Square root of 25 is 5, so pull that out in front of the radical and then multiply it by negative 1 to make it negative. And then the rad 3 has no perfect square factor, so it stays inside of the radical. Awesome.